Welcome to lesson 1.2 on order of operations. And I have some warm-up problems here, A through E, so please pause the video, work through those problems, and then unpause and we'll go through them together. Okay, so hopefully you're done with those problems, and I'm going to go and start working them. So for this one here, we have a war, right? More negatives than positives, and so the negatives are going to win, and there are going to be 3 negatives left over. For the next one here, this is an alliance of negatives, right? So we have a -5 plus a -4. Since they're both negatives, they both have on red uniforms, right? Because we're using tiles to represent those. That is going to be a total of 9 negatives that are going to team up together. Now these are the rules for multiplication, which is not wars and alliances, right? So for this, how many negatives are there, right? So 2 times 9 is going to be 18. But there's only one negative, and if there's one negative, then that answer is negative. Over here we have 6 times 3, which is also 18, but here we have a negative and a negative. So since there are 2 negatives, negatives cancel in pairs when you multiply or divide. So that answer is going to be positive 18. Now, this next problem, it's a word problem, and if you remember how to do percents. If not, it's fine. We're going to work through it together. But for this problem here, we have a humidifier that is on sale. So this is a sale where a $150 humidifier is 20% off. You also have a coupon for $10 off. What operations need to be done to calculate the sale price? Well, to take $10 off a coupon, we would have to subtract 10, right? That has to happen as part of our process. Then how do we find 20% off? So when you think about 20%, cent means 100. So it's really per 100 is what you're saying. Just like when you talk about a cent, a penny, right? A cent, there's 100 pennies in a dollar. A century has 100 years. So this phrase means 100. So when we deal with percents, we usually don't use them as a percent. We usually change them either to a decimal or a fraction. So 20% literally means 20 per 100, or this fraction. And you can convert this fraction to a decimal. There's 2 ways you can do it. So if I turn on my calculator here, hopefully you can see that well enough. Let me turn the light on for this. That's better. Clear that out. So for this problem here, 20 divided by 100, that fraction is 0.2. Or if we want to call it 0.20 so it looks like a 20, that's fine. So you can use either the fraction, 20 over 100, or the decimal, 0.2, and you would multiply it to the 150. So, I don't know if that's quite exactly accurate. You're going to multiply it to, we'll say, the price. And because it's going to actually change depending on what we decide to do first. So we'll just say to the price. Does the order matter in which you do them? Right? Does the order in which you do them matter? Does it matter whether I subtract first or multiply by 0.2 first? So if you said yes, then you were correct. If you said no, well, let's find out why. Let's actually do both orders, and we'll compare them, and then maybe that'll help us understand a little bit more why the order matters in which you do them. So let's do the first one. Let's take off 20% first. So we'll say take 20% off first. So I'm going to use the decimal form. So I'm going to take the 2.0 and I'm going to multiply it. And I'm going to use parentheses to multiply this. So I usually kind of stop using x as a multiplication sign once we start getting into equations, and we're going to get into it in this chapter. So I'm going to go ahead and start doing that now. So this would be 0.20 times the 150. And then I will subtract the 10 afterwards. So this is a calculator problem. I'm not expecting us to do this kind of math problems by hand. We have calculators. It's a great tool, so we should use them. 20% of 150 is $30. So this is actually going to be $30 off. Sorry, let me erase that real quick. And then, so we take $30 off the 150. So there's $30, so it's going to be 150 minus the 30, and that'll take us down to $120. Then subtract 10. So we're going to take the 120 and we're going to subtract the 10 from it, and we'll have $110 as the price of that humidifier. But what if we subtract 10 first? How does that change the problem? So we'll start with our $150, the original cost. We'll subtract $10 from it, and that puts us at $140. Right? Then we're going to multiply by 0.20. So we have 0.20 times 140. Do that in a calculator. So 0.20 times 140, $28. So we're now going to take the $140 and we're going to subtract the 28. That's our 20% discount. And so for that one, we're going to have $122. Let me erase this a little bit. Hold on. Let me double check my math here. 140 minus 28, right? So that's 112. So we wind up with $112 as the sale price. So it does matter a little bit, doesn't it? In this case, it was cheaper to take the 20% off first, then subtract the $10, than subtracting the 10 first and taking off 20%. Why do you think that's true? Well, in class, we talked about how when you take the 20% off first, you're taking 20% of a bigger number. So it winds up being a bigger value, $30. When you took the 20% off here, it's only $140 that you're taking it off. It's a smaller amount. And that's why it's only 28 as the discount amount as opposed to the 30. So it's actually an advantage to take the percent off first because you're taking a bigger slice. You're taking a slice off a bigger pie, right? And so that allows you to get a little bit more of a discount. All right. We're going to talk about order of operations. So this is your basic PEMDAS. Please excuse my dear Aunt Sally. You may have heard those terms used, but I do want to talk about each of these kind of individually. When we talk about the first step, parentheses. Now, parentheses, this step happens when there's something in the parentheses that you need to simplify down. If I look at this problem here, there is a parenthesis and there is stuff that can be made simpler. We could calculate 30 minus 3 and get a single value instead of two different values. So that's why you look inside your parentheses first. Now, if there's just one value in the parentheses, there's nothing to do there. Exponents. So that's when you have numbers up top like this. We'll take a look at that problem when we come to it. Please note multiplication and division. It doesn't go multiplication and then division. I put them next to each other because they're both as important. So it's multiplication, division, and then we're going to write from left to right. That's going to be really important. And let's go ahead and write the same thing for addition, subtraction. from left to right. Okay. And so for this step, if you're at the multiplication division step, you go left to right. Whatever happens first. If you see a division problem first, you do that one. If you see a multiplication step first, you do that one. Addition and subtraction, I would recommend doing the same thing. Sometimes I have students try and do it a different direction, and I see a lot of mistakes from that. So my recommendation is go left to right. So let's take a look at our first example here. There is parentheses here, so we are going to go ahead and do that. 30 minus 3, that is a war. Positives win, 27 left. So since that was in parentheses, we do that first. Whenever something's in parentheses, when I simplify it, I usually keep the parentheses around it. This is a good idea. There's a lot of times where you absolutely have to. There's sometimes when you don't. This is one time where you really don't need this. You could have just written 27 divided by 3. But I want to be real careful about that. If you're unsure, leave it there. Now 27 divided by 3 is just 9. And that winds up being our answer. Is it correct? We will be using calculators in this course. Calculators are a tool. They're a math tool. Not only do I let you use them, I encourage you to use them. Not to do your work, but to check your work. So when we're doing order of operation problems, I want to see all the steps. So please show me each step, one operation at a time, that leads to your answer. This is going to help me know that you know how to do your steps. But there's no reason why we should wonder if the answer is correct or not. So I'm going to go ahead and put a parenthesis here. I'm copying down this problem exactly. And then a 30. And then this is a true subtraction, so I'm using this subtraction button right here. And then a 3. And my parenthesis divided by 3. So that looks exactly like that. When I hit enter, I get 9. My answer was 9. So now I know it's right. So when you have quizzes on this, and you will have quizzes, you want to make sure and check each problem, get the answer, and verify that you did it correctly. We'll go to the next problem. So we have 1 plus 7 squared, or 7 to the second power. There are no parentheses to be seen, so we go to exponent. So this is 7 squared, or 7 times 2. So what do you think you would get for that value? What does it mean if something is to the second power, or sometimes we call it squared? Well, one of the reasons we call it squared is because the Greeks actually saw this as a square. So I'm going to go ahead and draw a square. And let's say it is a 7 by 7 square. So what would the area of the square be? When I say 7 by 7, we are literally dividing this into 7 columns and 7 rows. So that's 7 by 7, and if you were to count all the blocks in there, you would get 49. And that's because 7 times 7 is 49. And when you find the area of a square, you're really multiplying the side times itself. Now, this 7 squared, this is repeated multiplication. This tells you how many times you're supposed to multiply the 7. So I'm actually going to change this into a 7 times 7 just to remind us. I think this is a good habit to get into. When you see an exponent, expand it like this. And then we know it's 7 times 7 is 49. I really want to avoid trying to multiply this to that. That does not work. That's not what it means. If I want it, because if you multiply 2 and 7, you're going to get 14. That is the wrong answer. And I don't need a new way to multiply. I have lots of ways to multiply. I'm going to go over here to the side and show you all the ways I could multiply two numbers together. So if I wanted like 2 times 5, I could do 2 dot and then a 5, or a 2 and an x and a 5. Or I could do a 2 in parentheses and a 5 in parentheses. I could do a 2 and then a 5 in parentheses. This is still multiplication. The 2 is next to the 5. That is still multiplication. I could have left the 2 in here and put the 5 at the end. You usually don't see this. But if two things are next to each other, they almost always mean multiplication. So I have lots of ways to show how to multiply two things. This notation was created because we wound up multiplying the same number over and over again, and we wanted a simpler way to do that. So, for example, if I had 7 to the 4th power, that would be 7 times 7 times 7 times 7, right? So we want to simplify this, because what if it was 10 sevens? Do you want to write out 10 sevens? No. You could just do 7 to the 10th. So this exponent system was to make things easier. All right, sorry, let's get back to the problem. So we have our 49, because this means 7 times 7, and 49 plus 1 is 50. All right, that is the end of page 1. Please continue on to page 2.